Hi, welcome back. Let's take a look at a few problems now. On the left-hand side, we're going to convert some standard notation problems to scientific notation. Then on the right-hand side, we're going to convert some numbers that are in pseudoscientific notation to scientific notation. Now this next part's optional, but what I'd like for you to do is pause the video and see if you can work these out. Then we'll come back and we'll go through them one by one and see how you did. Okay, if you pause the video to work the problems, let's see how you did. On the left-hand side, we start out with 24 trillion. That's 24 followed by 12 zeros. To put this in scientific notation, we want the decimal place to go between the 2 and the 4. So you have the 12 zeros, and you add an extra decimal place to account for the decimal that goes between 2 and 4. So in scientific notation, you'd have 2.4 times 10 to the 13. So 24 trillion is a large number. This next one is a really small number. So you have a decimal point, and then you have 5 zeros, followed by 143. To write this in scientific notation, you want the decimal place to go between the 1 and the 4. So you take the 5 zeros you have, and then one more decimal place to account for the decimal that goes between the 1 and the 4, for a total of 6 decimal places. So if you were going to write this in scientific notation, you would say 1.43 times 10 to the negative 6. The problem below is similar. You're just counting more decimal places. Here you have a decimal point, 7 zeros, and then the number 715. Placing the decimal between the 7 and the 1 gives you the 7 zeros and then one more decimal place, for a total of 8 decimal places. So you would write this 7.15 times 10 to the negative 8. Again, you have a number here that contains 8 zeros and then 334. Since you put the decimal place between the two 3's, you'd have 8 zeros plus that extra decimal space. So in scientific notation, you would write this as 3.34 times 10 to the negative 9th. Next, you have a large number, 500 million, but it's negative. But that's okay, we just keep the negative here and count the number of zeros we have. In this case, 8. So we would write negative 5.0 times 10 to the 8th. And then again, you have a very large number, but it's negative. In this case, you have 1 trillion. So you have a 1 followed by 12 zeros. So in scientific notation, you would write this as negative 1.0 times 10 to the 12th. Now let's take a look at the right-hand side for pseudoscientific notation. The first number you have here is 140 times 10 to the 11th. So to this 140, you would add 11 zeros. But since you would want to write this in scientific notation as 1.4, followed by some number of decimal places or zeros, you would take the 11 zeros you already have, and then add 2 more decimal places, because you want the decimal to go between the 1 and the 4. So in scientific notation, this would be 1.4 or 1.40 times 10 to the 13th, to account for the 2 extra decimal places you need to add. And then here's an example going in the opposite direction. The number above was a very large number. This one will be a very small number. So you have 17.8 times 10 to the negative 7th. Since for scientific notation, you would want the decimal place to go between the 1 and the 7, you would actually start one more decimal place to the left. As it stands right now, you would have to go over to the left more decimal places than you need to. So by starting one more decimal place to the left, you would only need to go over 6 decimal places. So in scientific notation, you would write this as 1.78 times 10 to the negative 6th. Let's do a couple more of these. Here you have 157 times 10 to the negative 10th. So if you were to write this in standard notation, you would start at the decimal point and you would move it over 3 spaces so that it's to the left of the 1. Then you would move it over an additional 7 spaces. But since in scientific notation, you would start with a decimal between the 1 and the 5, you wouldn't need to go over 10 spaces. Starting with a decimal between 1 and 5, you'd only need to go over 8 spaces. So to write this in scientific notation, you would write 1.57 times 10 to the negative 8. And here's one that's a little bit different. So you're starting with 0.824 times 10 to the negative 8. But to write this in scientific notation, you would want the decimal point to be between the 8 and the 2. So to write this in scientific notation, you would start with the decimal point between the 8 and the 2, and you'd have to go one more space to the left. Here you're already going 8 spaces to the left, but you need to add one more. So you would have 8.24 times 10 to the negative 9. And then below, you have a large number, but it's negative. So you have 50,000 times 10 to the 3. So this is a negative number, but what you would be doing is adding 3 zeros. And this would give you negative 50 million. Since you'd have a total of 7 zeros, you would write negative 5.0 times 10 to the 7th. And in a similar manner, below you have a large number, but again it's negative. So you have negative 1,000 times 10 to the 9th. So to get this in scientific notation, you'd want the number in front to be 1.0. So to get this in scientific notation, you would say negative 1.0 times 10 to the 12th. I hope this has helped you out. If it's helped you out at all, I'd highly recommend going back and reviewing this lecture. And if you didn't work the problems the first time, even though you've already seen it, try to go back, pause the video, do the problems yourself, and then look at the answers. Okay, let's take a break. When we come back, we'll talk about performing arithmetic operations with scientific notation.